All right, guys. Today I'm going to show you how to make a Unity game in Unity version 6, LTS 6000.3.11F1 because Unity is really great at version numbers. So we're going to speed run building our own version of Space Invaders. If you were born in this millennium, Space Invaders was a very old game, one of the first, where you were a little tiny ship and you would shoot bullets up and you would kill these aliens coming in to invade. So we're going to do that in Unity as fast as we can. Let's go. So head over to Unity Hub. Make a new project. Make sure you're using the core scriptable render pipeline universal 3D template. We're going to call it Invader, and I'm going to create the project. Your life will be easier if you are on the same version of Unity as me, but as long as you're 6000.3.10 or higher, you'll be fine. All right, let's roll. I updated Unity just for you, so it might take a minute. We have people of all different levels coming in for this course, so some things you might be really familiar with, some things you might not be. And so either way is fine. So as we continue, you can ask questions in the comments and then I will answer them and go over the things that people need. So I'm going to try and be as thorough as possible while moving quickly. It's a tough balance. We'll see if we hit it. All right, while Unity finishes loading, I'm going to have you guys pull up this URL. So this is a little framework I built that makes some of the annoying things in Unity less annoying. In order to do this fast and teach you some important concepts about Unity, we're going to use this library as we go. It's actually really easy to set up and install. Go to the URL here. You can it'll be in the description. And if you copy this right here, a little copy thing right there for you. This is a GitHub URL. If you're not familiar, GitHub is where software developers store their code. We're going to get into it, don't worry. But for now, just go to this site, copy this link, and then when we get into Unity, the first thing we're going to do is we're going to set up and install this package. So Unity should be ready for us by now. So I'm going to scooch my window into the viewable area for you guys. And scooch. All right, great. So I'm going to do a few things to make this reasonable. I'm going to put console here so my dumb face doesn't block anything important. We will need the animation timeline, but not quite yet. So we're going to start by going to Window, Package Management, Package Manager, and we're going to add the package I showed you in a very specific way. So I like to dock the package manager because sometimes you use it a lot. So I dragged the tab up to this area. So now it's up here and I can switch between things. You all know all that. All right. So if I go here and I hit the little plus sign and I say install package from Git URL, I get to paste in Dark Magic, this framework I built to make Unity easier. So if I hit install, it's going to think for a minute and then boom, Dark Magic. Let's see what it does. Hopefully we don't get any errors, Unity. But no, we're good. And so it's saying, hey, do you want to import some things that came with the package? We can just go ahead and say yes, and hopefully it won't give us a headache. The package does a few things. It adds an event bus system, input wrapping, some async helpers, some UI sort of easy starters, and a bunch of other things too. So it's actually pretty cool. I've loved working with it and I loved working on it. And I think it just gives you just enough to get rolling and not get hit by those roadblocks that pop up in early Unity development. So we are going to use it. I'll explain it as I go. In a later video, I will take you through how I created it and what it does. But I want to be clear. This isn't like a magic bullet, do everything for you framework. All it is it sort of lets you do real game development a little more seamlessly, right? So instead of getting stuck on the things that Unity does that are kind of annoying, this kind of puts those aside so we can work on actually building the game. And I'll show you what I mean as we go. So it's free forever. So if you grow to like it, use it in your projects. That would be great. Over here in the console, it's like, hey, the event bus is installed. Yay. And, text Mesh Pro Essentials not imported. Go to Window, Text Mesh Pro, Import Essential Resources. We already did it. So that is a stale error. So we hit clear and we're good. Just one thing while we're recording, if I hit a key, it's going to show up in the little bottom left corner there with my face. So when I'm switching tools, you can see, I'll try to speak it when I do that, but just in case I don't, we've got the keystrokes there to keep me honest. And anywhere I click, you'll get a little red circle just so you can follow along. Hopefully that helps keep this manageable, All right. So we've got our library installed. We've got a blank scene. We're going to start building Space Invaders. I think this is going to be a lot of fun. So first thing we're going to do is get our arena set up. So to keep things simple, I'm going to have us work in 3D, but sort of act like it's 2D. And we're going to learn some of those details soon and why. But I think for getting started and having fun, it's probably the easiest way to do it. So to kick it off, I'm going to just create a background. So we'll create a 3D object. I'm going to call it a cube. I right-clicked to do that. Created a cube. I'm going to put it here. And I'm going to make it like, I don't know, 50 X scale, 1 Y scale, and 50 Z scale. So if we look, we've just got like this big old square, right? Not too bad. I want to make sure that it's at 0, 0, 0, because it makes math easier to do later. Paying attention to where things are is actually quite important when you're building a game that you want to work reliably. If something gets off by a little bit, it can start to drive you nuts. So I'm going to take the game view and pop it down here for now. I'll probably move it a lot. Unfortunately, with Unity, it seems like no matter how big your screen is, there's never enough room. So, get comfortable moving the panels around. It's super helpful. And depending on what you're doing, different layouts work better. So we've got this cube, right? So we're going for like a space vibe, and we're going to do sort of like a top-down camera. So it's going to have the illusion of being 2D. I'll show you in a minute. So I'm going to go into my assets. I'm going to create a new folder. I'm going to call it materials. We're not going to be using assets per se in this game. We're going to be using the built-in Unity stuff in pretty cool ways to get the effect we're looking for. Again, this will help us build quickly and let me focus on the development stuff, right? How do I build this? What is the code doing? What does the game need to actually function? That's the stuff we're going to be looking at. So in the materials folder, I'm going to right-click, create a material. Cool. And I'm going to call this dark. And I'm going to go over to my material here and let's play with some settings, right? So I go here and let's do sort of like a very dark purple to feel like space, So maybe like this guy, all right? And space is space metallic? No. So we're going to make it matte, the opposite of metallic. So that's 0 on this metallic slider. We can play with this too. Smoothness makes it kind of flat. This makes it sort of bubbly. And so, kind of around here is nice. And yeah, we can start with that for now. And so quickest way to apply a material is to drag and drop it. Okay, so there's our sort of background, our playing field, right? Now let's create a player, right? We're going to go right to it. We're going to make a few things that we can start manipulating in the scene, and then using code, we'll make them do cool stuff. So I'm going to right click in here, a 3D object. I'm going to make a sphere, and I'm going to call it player. Cool. And down in my materials, I'm going to make a new material called player. Right? And we want the player to look cool because that's what makes games fun, partly, right? So I'm going to just pick like a blue color. And again, I'm going to play with these settings. Maybe I am a little bit shiny. Maybe I'm a little bit smoothed. Whatever. We can do whatever we want here. Have some fun, play with it. But I'm going to play with the emission. So this is a cool feature where Unity can actually make materials push light out into the world. So I'm going to do the global illumination is real time. And we're not going to have too much going on, so this shouldn't be too much of a hit in performance. So I'm going to go into this color here for emission map and pick the color that I want it to sort of glow. And then if you want it to really be bright, you've got to use this intensity slider here and crank it. Maybe not all the way, but pretty high. And so that's going to make it so that when we apply this material, which we can do right now, we're going to apply it to the little guy, little player right there. And I'm going to click on him and I'm going to just move him up a little bit, right? He's currently inside. You can see in our game view, he's inside and he shouldn't be. So let's, make him 1. So he should be sitting just on top, and the very 1 pixel of the sphere should be connecting with the ground. That's fine. And you can see he's casting light. But since this is a space game, let's take our directional light and bring it down. We probably don't want, so much light. We want to bring it down so that we can see the lit objects in the scene a little more. So you can see that as I did that, everything got darker. If I crank the light that came with the scene up, it gets bright. If I crank it down, it gets dark. So I'm going to go real dark, like 0.5. It doesn't have to be exact. That's fine. And that will make our lights that we use pop a little more when we play the game. All right, cool. Let's do some enemies. I'm going to create a cube. You know, cubes are evil, as we all know. And I'm going to create the cube. I'm going to name it enemy. So you can double click to you can click once and hit enter to rename. No, that's not working. You can right click and say rename and do enemy. And just like player, I'm going to actually, you know what, shortcut, I'm going to duplicate Command D, the player material, and I'm going to rename it to enemy. And I'm simply going to change the color to sort of like a gnarly green, right? And I'm going to do the same thing for the light. Let's do this gnarly green. We want these enemies to be green, because as we all know, green is evil. So I'm going to drag this up here. Ooh, yeah, that's kind of cool. So already we haven't done anything, and it kind of looks cool. All right, so let's get a sense of where things are in the world. So I'm going to go back to I'm going to zoom out quite a bit, and let's figure out where my camera is, right? So, you know, as sort of a compromise to get things rolling, I'm going to do this sort of like 3D camera, but used in a 2D way. So let's take a look at the camera's position right now. So the camera is at Z-10. So if I change that to 0, the camera is now in the direct center of the world, right? It's in the direct center of our square because we reset the position as well. So to see the action, maybe there's a few ways we could do it, but I'm thinking the camera is going to be above the square looking straight down, and then we're going to do a trick to flatten everything so it's almost like 2D, but we still get to work in 3D and use those effects. So that's kind of what we're doing today. So I'm going to stay in the center here, and I'm going to raise up my X position to like, let's say 10. And then I'm going to play with my different rotations. So rotating this way on the y-axis, if you think about it, the y-axis is tall. So rotating along that is rotating on the tall way. So you can see it's kind of like shaking its head no. So that's not what we want. If we look at the x-axis and we change that, it's kind of going up and down, nodding its head yes. So that's kind of what we want. So I'm going to push this down to, oh, I don't know, let's say 90. And it's looking straight down onto the field. And so if I go to my camera settings, we can sort of figure out like, okay, well, that's a little zoomed in, right? So if I zoom out, can I see the whole square? Okay, great. There is the whole square. And so that's cool. And I guess we could be clever and make the cube, you know, we're going to be doing a 16:9 game, right? So 16:9 aspect ratio, if you don't know, it's widescreen. It's standard widescreen. Your TV is probably 16:9. 1920 by 1080 is the most common resolution for like everything. And so that's kind of what we're going to be building for in our minds. We can later on make it more responsive and more flexible, but to get things going, we're going to do the good enough version for a lot of stuff. And that's a good thing, not a bad thing. Game development is full of endless details that will totally trip you up if you let them along the way. So I'm going to rename this cube ground because I forgot to before, which is kind of a misnomer because we want it to look like space, but hey, it's still going to function like ground. And then instead of 50 by 50, right? So 1920, okay, 16:9 is an aspect ratio, right? So if this was, well, we can actually just do that, right? So if it was 160 by 90, there we go. That's going to conform to the aspect ratio. And the problem is, I think if we do that, we go to our camera and we change the field of view, it makes everything quite small, right? So let's cut that in half, right? Maybe that is a good way to do it. And again, there's so many ways to handle cameras and projection. We could be doing 2D. We could be, you know, handling this so many different ways. I'm trying to pick something that's going to work, but also get us moving, right? So half of 160 is 80. And half of 90 is 45. And now we know that this rectangle is 16:9, so it should work with what we're doing. If I go to the main camera and then I zoom in the field of view, come on. You can see how it's filling the game view on the bottom right kind of perfectly at that level, right? And so I have this perfect downward view into what's going on. So it's honestly still a little bit kind of small, but as we have, you know, a dozen enemies and you know, things like that, maybe we'll actually be glad that this is what we went with. So we'll play with it. But for now, I think this works. So your ground, if you're paying attention, should be scale X80, Z45, and Y1. So just take a look at the upper right of my screen and make sure yours is the same. We can again play with things. I can take this directional light, and everything still looks a little bright. So if I just turn this off, right, what happens? Okay, that's fine with me. We don't need that light, so I'm actually going to delete it because it's not necessary, and why have extra stuff? One other thing we can do is if we want an even more flattened look, instead of perspective, we can change the camera to orthographic. Orthographic, and we'll have to change the size again, but orthographic is a flattening camera. So if things would have seemed, one thing was further and one thing was closer, it kind of flattens that. So everything appears on the same plane, even if it's not. And so 2D cameras tend to be orthographic, and you can use it for certain effects in 3D spaces. And, it might be good for what we're doing here. But again, if I zoom out, we're going to have a similar kind of functionality. We're eventually going to hit the edges, and it's still kind of the same size, right? So we can zoom in slightly. Okay. So we're going to start with this. I like it. I like it a lot. So we've got our setup. We've got a player, we've got an enemy, we've got our ground. And, let's take a look. So we know if our ground is 80 wide by 45 tall, if I want my player to be at the bottom of the ground, I can go to player and I can say, you know what, your position should be, let's say negative 45. And he's a little too far, so let's say negative 40. Did I mess it up? Well, here, we can do it this way. And this is the fun of working in 3D. Because it's half, right, sorry. So let's do negative 20, right? And so it's because the whole z-axis of the scale is 45, and it's centered at the 0. So plus 20 would be going toward the enemy, and minus 20 would be going toward the bottom edge. Cool. So we've got our player at minus 20. Let's put our enemy at positive 20 and make sure he is on top of the ground and centered. And there we go. Face off. We're ready to go. So already we've done some cool stuff, but it's pretty simple. But I think getting into the interactivity is kind of like the thing we're aiming at. So there's so many things we can do to make all of this better and more interesting. But for now, we are starting with this. So let's continue. Because I'm, I like to have a little bit of fun with the creative side as we go. So I'm going to take this. Oh, our color is getting cut off. I hope it wasn't like that before. Sorry if it was. So just in case it was, I'm going to show you in the inspector. You can click the color and you can change. And as I'm changing the material stuff, you can see it changing in real time. And the background for the ground is not illuminated. It's not using an emissive material. But if we go to the enemy material, for example, you can pop the color and it keeps trying to shove it off the screen. So here you can see I can change this by messing around. You can see the enemy is changing as I change these things. Well, it would be here. It is, but the light is too intense, so you can't actually tell. So if I change the light, then you can see it, right? Oh, it's kind of fun with the red. Maybe we go with red. As evil as green is, red looks kind of tight. So we're going to do that. So I just wanted to show those again because I think they might have got cut off last time. And if you want to change the lighting intensity, it's this slider here. And it's pretty cool. It works well. And so you can, get a sense of what's happening. If you look at the scene view right now, you can see as I increase the light, it gets more and more intense. So since we're using very sparse objects, no assets, we're using geometry, we're going to get a lot of mileage out of our materials, out of our emissive lights and other effects. So we'll be doing that. So, all right. Now what you've all been waiting for, actual game development. We're going to put a script on our player and see what happens. I saved my project and you should too. So I'm going to go to player. I'm going to add a component. We're going to call it player. I guess we can call it player controller because that's probably better. Well, before we get started, this is game development, right? We're going to do this right. So I'm going to create a class that we can apply to everything, right? Because a player is going to have HP and an enemy is going to have HP. A player is going to have a movement speed. An enemy is going to have a movement speed. So we're going to design it so that we create a parent class that can give some stuff that every every type of thing is going to need. And then we can inherit from that parent class as we go on. So I'm going to make one called entity, just to be dramatic. I'm going to call it entity, create and add. And to start, we're going to add it to the player. Lately, for me on Mac, Unity's not been adding the .cs, so make sure you do that. Hit save, and it should create a new script in your assets folder. We give Unity a minute to think. We go to assets. I'm going to create a new folder called scripts. I'm going to drag that entity folder into scripts. I'm sorry, that entity file into scripts. It's going to think for a minute, make sure we're good. And anytime I create a new script and move it, Unity can sometimes be a little bit whiny. So I'm going to edit this script. Say edit script. Okay, fine. I'll go over to player and I'll go to the 3 dots here, and they let you say edit script, and that should open up my text editor. For me, it's VS Code. I'm assuming you guys have got this all done and figured out. I'm on my second non-standard computer, so if it's going to give me some problems, that's fine. I'm just going to not sweat it and hope it all works okay. Yeah, my main computer, the hard drive is full, so we're on the backup today. All right, so here I've got this entity. I'm just going to be like debug.log sup. And now I go to our beautiful game. I hit play. Always waiting for Unity. And over above my head in the console, it says sup. So we know our script is alive and well and working. So entity is going to be very basic, and we're later going to customize it and inherit from it so that players can have different functionality than enemies, and maybe bosses can have different functionality than enemies, right? So we can do, we're going to build this in a way that's, hopefully reducing repetition, right? In programming, DRY, don't repeat yourself, is a big thing. So we're going to get rid of this debug.log. And any entity is going to need a few things, right? So I'm going to say public int HP, right? Everything's going to need HP. Public int, and let's make it a float, and we'll say speed, right? Things are going to move. How fast are they going to move? Let's see. And you know what? I don't know yet. We're going to discover this as we go. So the dirty secret is I've actually already built this in a side project, and I can show you that some other time. But I'm trying to go through this process as if it's my first time, because I can then talk through it to you guys in a way that's a little more natural and more like the actual problem-solving process. So we'll see if that works. So I know, enemies, bosses, player, even probably like random objects are going to have HP and speed, right? So we're going to need at least that much. So that's all. We're going to keep this as the base class from which other things will inherit. So what does that mean, right? So I'm going to create another script. I'm actually going to take entity off of player. So we're going to go here. We're going to say remove component. And because of the way we're architecting this, player is going to have a player script. I'm a rebel and I like to name things just player and not player controller or player blah, blah, blah. Maybe that's a bad habit, but it's what I'm doing today. So I'm going to make sure I add the CS and I move it to the scripts folder. Okay. And yep, save. And now if I edit this script, and I know the beginning is always a little slow. Hang in there with me. You can't see the right click menu because Unity's being dumb, but I'm going to click these little 3 dots on the script and go down to edit script. That's going to pop open my VS Code. I'll make it bigger. Well, not that big. So you guys can follow along. I don't use the chat. Okay. And then, so now we have a player thing. So almost every script you've probably ever written in Unity inherits from mono behavior. We can see that with public class player, mono behavior. Well, it turns out the colon in this case means inherits. So everything about a mono behavior is part of this player script. That's why we can use things like start and update. But what we're also going to do is we're going to get more specific. So I want player to also inherit everything that entity has. In this case, it's just HP and speed. And since entity inherits from mono behavior, there's like a chain, right? So mono behavior is inherited by entity, and then we're going to go to player, and we're going to say player inherits from entity. So player is still a mono behavior, but now it's this as well, and that is also a mono behavior. So this is inheritance. It's a very useful thing. It's a fundamental core piece of object-oriented programming, which is what we've been doing all along. So even though Unity puts a bigger focus on componentization rather than inheritance, inheritance is still useful to know. And so we're doing it. So over in player, we can assume, well, player is going to have some HP, right? And if you don't believe me, let's go back to the editor. And now that it inherits from entity, and it has those public variables, hey, look, we can see, we can give the player HP and speed here in the editor, right? So even though the player script itself doesn't have those written explicitly, it's still part of it because it inherited from this. Cool. All right. So in player, what do we want to do? Well, I think the most fun thing we can do to start is to be able to move our player. That's a pretty fundamental thing you need to test a game. So we're going to get some input happening. Now, around Unity 6, Unity updated the input system and kind of defaulted to using the new version. The new version of the input system is great, but it's a lot more work to set up and use properly. And I miss the old input system, which rough around the edges was quick and dirty. A couple lines of code, you were already ready to go. So that framework we installed at the beginning of the video, right? It's part of our project. So I'm going to, in my player, I'm going to say using dark magic. And what I've done is I've sort of pointed this script to that framework, and it says, hey, anything that's part of that framework I can now use in this script, right? I called it dark magic because it's a lot of strange ways of working around Unity's annoying bits. So dark magic gives you something called I, the letter I. It's a class that wraps around input and makes it feel like the old input system, but it's using the new input system under the hood. So if you've followed Unity tutorials before, you're probably used to saying something like, if input.get key down key code dot space, something like that, then do something. Well, Unity took this out. The syntax for this is way different now and requires some setup. But I added it back in with this I package. So instead of input, you can say I, and then you can use things like get key down and the key codes and sort of the way it used to be, but in a future-proof way that's using the new system under the hood. So it's a convenience thing, honestly. That's really all it is. So that's what a lot of this framework is about. It's just simplifying the stupid stuff you bump into when starting a new project. So let's see if this works. So if I press the key code, if I press the space key while update is running, I should see player, right? Let's see if that works. I'm going to bonk over to Unity. Okay, no errors. It recompiled. We're going to hit play. All right, I'm going to make sure game view has focus. I hit space and boom, player, right? So that worked, which is great. So that's using our new framework, which gives us back the old syntax for writing input the way we used to. So if you are happy with the new input system and already have it set up and whatever, like go for it. I'll do a longer video on that at some point. It's a super great system. I'm not saying it's bad. I'm just saying I missed the old syntax because it was quick. So for something simple like this, I want to use that syntax. So using dark magic allows you to use this I object, which contains the syntax for this input system. So I hope you like it. And just in case you're not familiar with using new packages, if I get rid of dark magic and I go back to my project, it's probably going to complain and it's going to say the letter I, the name I, does not exist in the current context, right? So it's important when you're using an external library to make sure you include its namespace, and that's what this using thing is at the top. Again, you've probably seen that in a lot of Unity stuff. So, all right, we've got our player, we've got some interactivity happening, but we don't want to just, we don't want to just like say player, if we hit the key code of space, we're probably going to want to like shoot or something. So I'm going to put, shoot. in here. So it's sort of like a function we're gonna write, void shoot, and it's gonna do something, and to do make this work, right? And I'll say debug.log, not yet. But you can sort of get the pattern of how we're going to go about doing this, right? So in the update, I'm going to be checking to see if the player hits the spacebar. If they do, we're going to shoot. So that's one thing. We're also going to, in the update, I'm going to write a function just called handle movement. I'm writing this function, but it doesn't exist yet. So we're going to go down here and we're going to make it exist. So void, you've probably been seeing these patterns in Unity, but you might not know what they all mean, right? So a couple of things. I'm going to write it out and then I'll explain it. Okay. A function, also often called a method, we'll get into the difference someday, but a function is sort of a list of steps you want the computer to do when you give it a command, right? So I'm now creating a command called handle movement that I want it to do every single update. So you can spot a function by the parentheses, right? So handle movement has an open close parenthesis right after it, right? Attached to it, no space. So that's one hint that I'm looking at a function. And again, when I see a function here where it's just handle movement, open close parenthesis, that's calling the function. To use an analogy, that's like casting the spell. Whereas down here on line 20, we're declaring the function, which might be sort of like writing the spell in your spell book in advance, right? So what I'm saying here is do the list of steps that I have labeled handle movement, right? On line 20, I'm saying, okay, computer, here I am now giving you the list of steps that I have named handle movement, right? So I could just be like debug A, B, and C, right? So every time handle movement runs, it's going to say ABC, 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 because I've given it this list of steps. And so that's what we're doing here. On line 12, it's going to do all the stuff down here in this spot. You guys probably already get all this. I'm not going to belabor it too much. If you have more questions about it, let me know in the comments and we can chat about it. Again, people of all different backgrounds are watching this, so I'm trying to give some context without burying everyone. It's a tough balance. We're going to make it work. And so instead of doing a bunch of logs every single frame, we don't want that. But we do want to see, did the player try to move, right? So if, that's fun indenting, I.getAxis horizontal, and this is the player trying to move left and right, whether with the arrow keys, the WASD keys, the joystick, are they trying to move left and right? Left and right. Get axis horizontal. Let's do something with that, right? So I could just say debug.log moving, right? So we're just testing this out, right? So if I.getAxis horizontal, tell me if we're moving, right? So let's go back and make sure we haven't broken anything yet. Let's see, cannot implicitly convert type float to bool. Okay, yeah, that makes sense. So my web development is showing. Web development languages tend to be a lot sloppier. They let you do weird stuff, like treating a true or false as if it's a number or vice versa. You can do stuff like that. You're not supposed to do that in C#. C# is a strongly typed language, which means it's persnickety. But it's good because it keeps you from making bugs that you would have made otherwise. So instead of putting this here inside the if, I'm going to do it a little differently. I'm going to create a variable, and actually, all right, let's just do it the right way. So at the top, I'm going to create a float called movement, and that's a variable we're going to reuse. But by creating it at the top, Unity knows to keep that variable around. Instead of if we created it in here, it's going to create it every single update, and that's going to take up more memory, right? So it's a little more efficient to create the variable once at the top of your class and then use it down here. So we're going to say movement equals, i.getAxis horizontal. So what this does is this will return a number that correlates to how much the player is trying to move left or right. So if it's trying to move left, it'll be a -1. If the player is trying to move right, it'll be a +1. So if they're not moving at all, it's going to be 0. So movement is a variable that's going to hold that value that we're getting from the input system. So what we want to do here is if movement is not 0, then we want to debug.log. So let's see if this works. You can see our error has gone away. We're going to hit play. And if you look in the bottom right, nothing happens. But if I hit left or right on the arrow keys, you can look at the console. We got 17 notifications, which means for 17 frames, it was trying to move. And there you go. So we are successfully detecting the input to move left and right. Let's actually now make it do something. So I'm going to stop this. We're going to go back into our script and we're going to say, okay, instead of just moving, we are going to delete this line. And we're going to put in a simple move that we will probably change later. But for now, like I said, I want this to be organic. We're doing it bit by bit. So I'm going to say transform dot position is now equal to what my position was. And then I'm going to use this helper function from the library. So set x. And we're going to put movement in here. So what this is doing, and I'll explain it all in more detail, but for now, there's a helper function that anytime you have a vector 3 that you're working with in the code, there's a new function part of it called setX. And so that will change its X property of the position to the new thing, right? So setX is interesting. If I hit this, it might, move the position by 1 or by -1. We can see what this looks like. Let's go ahead and see if it gives us the errors or if things are good. Whenever you're on camera, you're like, everything's going to go wrong, right? But so far, so good. So I hit play. And if we watch very closely, look at the player, the blue one. I hit left or right. I can either move to -1 or +1, right? So those are my only two options though, because I'm using set x. So of course, if I'm setting the position x to be either 1 or -1, that's just what it's going to do. What I want is to not set it to x. I want to add that. So wherever it is, if I'm going to the right, it's going to add 1 based on where it is, and then go further right, and then vice versa for left. So let's try that, small change, but I hit play. I hit play. I don't know why I said it like that. All right, so now, hey, I'm moving. How about that? So it's pretty fast, right? So we should think about that. We haven't done anything to control it, with the frame rate or the speed. So it's a little bit out there, but hey, we're moving, right? So that's progress already. So back into the code, this is pretty cool. So one thing we can do is, you probably have seen this in your Unity travels, but if you want to make something frame rate independent, and we can talk more about what that means, you have a float value and then you multiply it by time.delta time. And that's a built-in Unity thing, which is the amount of time since the last frame started. And it's usually something like 1/60th of a second, some small float decimal number. And by doing that, sorry, allergies. By doing that, if you have a slow computer where you're only getting 30 frames a second, the delta time number gets bigger so that it adjusts, properly. Whereas if you have a super fast computer like 120 frames a second, the time since the last frame is super small, so it slows down what you're doing. I could get into it more, but that's the gist. And if you have more questions, someday. So we're going to multiply it by time.delta time. So that's a very small number. So we're probably going to see, whoop, that's not what I wanted. We're probably going to see a very small movement now. Oh, I didn't quit. Hello? Oh, there we go. So now I hit play again. Okay, still moving at a pretty good clip. Neat. Did I save? Yeah. Transform, add x. It's movement times time dot delta time. I would have expected it to be slower, but it seems to be working. So interesting. So movement is 1 times a small number. Just for giggles, let's debug.log time.delta time. Right, so that was the right thing. So I hit play. Let's just see what it is, so we can think about it. So I hit play. Just thinking for a second. And then I hit the arrow key, and I get a bunch of really teeny tiny numbers here, right? So 0.0039, right? And so my computer's probably, yeah. So doing fine. These are pretty small numbers, so it means I have a good frame rate. But yeah, so I would have expected it to feel slower, but I guess... Oh, there we go. So it just hadn't taken effect for whatever reason. So yeah, that makes me feel better. So that means we are on the right track. You can see how slow it's moving now. Kind of excruciating, right? So we go back to the code, and the way we fix this is we multiply it again by speed. So problem is, speed is a public variable that we inherited from entity. So if I go back into Unity, if I were to hit play now, no movement would happen. Why? Those of you following along at home, it's because speed is 0. But if I make speed 5 or even 10, now I hit play, and I'm going to get a frame rate adjusted, reasonable movement speed for our character. We can playtest this. That's why we made it a public variable. We might find it feels a little better if we bump it up to 15. You don't want it to be too fast, and you want to leave some room to grow, because maybe you have a speed power up later or something, right? So yeah, 15 feels kind of nice. So we'll keep it there, right? Later on, we might add the ability to move up and down a little bit. We'll see. I don't think the original Space Invaders had it, but this is our game. We can do what we want. So while we're here, let's give the player some HP. Maybe 3 is the default. They can take 3 hits before dying. We'll play with it. It's hard because game design and development is like a symphony or an orchestra. A billion little details have to come together, right? Not just the horn section and the strings section, but every individual player in each of those sections. And then the melodies they're playing, and they're all different, the individual notes. It's a big, complex, interwoven, interlocking thing. And so you can get hung up on any number of details at any point in the process. And the number one skill of people who actually finish games is being able to say, good enough. If it's important, I'll come back to it later. I really mean that. And so keep that in mind. So we have got our player, they're moving, life is good. It would probably be cool if it could actually shoot, right? So maybe that's the last thing we'll do today, because this video is getting long. But hopefully, it's given you a sense of where we're going to go and the kinds of things we're going to do. So if we go over here, I created a function that allows me to shoot, except nothing there yet, right? So let's think about how we want this to work, right? When I press the space key, I want a bullet to appear and move forward, right? So that means I'm going to need a new game object, right? I need an actual bullet. So let's build one. So I'm going to go to Unity, and I'm going to right-click in here, create a 3D object. Let's do a little, let's do a capsule. Why not? Let's make it funny. We'll do a bullet. And, maybe we're going to have enemies that have bullets, but for now, well, let's call it player bullet just to be safe. So we've got player bullet. If I double click, it's going to zoom into it. And okay, so we're currently inside the ground. So we're going to fix that with position Y up to the 1. And I want this to sort of be on its side, like shooting forward almost, and maybe we can make the scale a little, not like that. Let's make it, 1 looks fine. This is a dangerous game. But let's make it look cool. So we're going to go to the materials, and I'm going to create a new one for the player bullet, new material, player bullet. And as a fan of Mega Man, I'm going to make it sort of yellow, orangey, Okay, that's fine. And then I'm going to make it, you know, why not? Let's make it weird. Let's make it smooth and metallic. Jesus, what's that about? All right, let's back off that a little bit. And then we're going to give it an emission, because the thing that's going to make this game look cool is the lights and the effects. So we want to make sure we're capturing that and doing that right. And so here we go. We've got this sort of like neon bullet, flying through, and we probably want that to be like extra bright so it's exciting. So yeah, so we'll play with that. Let's see how that feels. I'm going to add that to the capsule. Whoa, hey, okay, great. And yeah, whoa, that's okay. That's probably a little too much, right? This is just a basic bullet. It's not like a nuke. So we're gonna bring it down a couple notches, so we have somewhere to build to. Yeah, we'll start with that. And I'm realizing the capsule just feels a little weird, so I'm going to make it a little smaller. And yeah, what do we make it like? That's like a beam, Let's try that. Whatever. It doesn't actually super matter. So what we're gonna do is we've got this player bullet, right? But you don't want to just start the game with a bullet hanging around, right? And so we're gonna start the next phase of this. We're gonna go to our assets folder. We're gonna right click, and we're gonna create a folder called prefabs. Excellent. So in prefabs, I'm going to drag and drop this bullet. And that's it. Now we've created a prefab. As you might know, a prefab is kind of like a template. It's a game object that lives in the file system that you can then generate later on. There's a few different ways to do that. We're going to talk about the pros and cons of each, but now we've got this object that we can instantiate. That just means create an instance of this thing in the world. So by doing it this way, we don't actually need to have a bullet in the scene anymore. And when we need it, we're going to create one with code. And so if I double click here, I can edit the prefab. I can change it and make it do things. And the job of a bullet is to move forward and see if it connects to something. So we're going to start that process by creating a script. So I'm going to create a new script called player bullet. Yep, .cs. Again, I don't know if yours is still putting it on by default. Mine stopped for some reason. Unity's finicky. All right. So I've got this player bullet. It's got this script on it. And for now, I'm just going to keep it really simple. We're going to just make it move forward. Today, the video's going long. We're going to wrap it up in a minute, but I just want to show you the gist of what's happening here. So, maybe a player bullet, needs to know, like int, maybe what you need to know is how much damage it would do if it hits. Damage. And let's just make it 1. We don't need to edit it in the inspector since we're generating these from code and there won't always be one in the inspector. So I think it's fine to do it this way. So we'll come back to that. But for now, we're just going to say, hey, move forward, right? So during the update, its only job is to move toward the enemy, right? So we're going to do transform dot position is now equal to the old position. Should have talked through this before, sorry. Dot add, what are we adding? I think it's Z, because we're going across the ground. And then we can just add an amount. Let's just say 5 times time dot delta time times speed, right? And so maybe we want to be able to change the speed so we can test what it feels like. So I'm going to also say int speed equals, I don't know, 20. That's going to be really fast. So let's see what that does. So a couple of things. You might be asking, well, gee, John, if you're giving it a speed, shouldn't you have just maybe inherited from entity? It's a good thought. If we set up entity so that anything that is an entity could be hit by something else and then destroyed, we might not want that for a bullet. Don't let perfect be the enemy of good. Don't repeat yourself as great until you get hung up on building the perfect system and not doing anything wrong and all that stuff. So it's always a balance, a give and take of like what's conceptually maybe perfect and what's going to get this project done. We might go back and change it later. Refactoring is a thing and, maybe we'll get there. But I think bullets might be different enough that we didn't want to make them also an entity, but we could. So again, on line 14, every frame, it's going to say my position becomes my old position where the Z has this number added to it, right? So let's go ahead and see if I go to my code. We got a problem. Vector 3 does not contain a definition for add Z. That's weird. It should. And then this says player bullet damage is assigned but never used. That's okay for now. We're going to use it someday. So let's go back here and figure out what's wrong. Oh, this is a great learning moment. I forgot to type using dark magic. Honestly, we're going to be using some of these things a lot. And so just try and get in the habit of using dark magic to all of your files. Again, it basically gives a few quick shortcuts to make things easier. For example, this add Z function is very useful. If I were going to do it without that function, I'd have to say transform.position is now equal to transform.position. Actually, it's even worse than that. You have to do new vector 3 and then my current position X, my current, oh my God, hard to type when you're on camera, transform.position Y, my current Y, and then transform.position.Z, which is times all those things, right? So times 5 time.delta time times speed, right? So you can see that's just much more annoying to write. Here we're doing the same thing. Our transform.position becomes what my current transform.position was, but I've added a number to the Z. So under the hood, this function is just returning a new vector 3 with the values it had, with the Z being the only one changed by this amount. But you can see how this is nicer to write, you know? So I'm going to leave this here as an example of, where this line actually does, but you can see why I took the time to add in these helper functions, because it just saves time. And it's just nicer to write. You get to stay in the flow of getting things to do what you want. You're just a little closer to it being, I don't know, the way I feel like it should be, right? Maybe that's just me. If you like it, I hope you like it. Keep using it. But yeah. So I'm going to leave this here as a reference, but I realized the 5 was kind of serving the purpose of speed. So I'm going to get rid of that. And I'll get rid of that from the example we saved too. And so if speed is 20, yeah, let's see we'll just test it, right? So the player bullet now, whenever it's created, is just going to automatically move that way. So I go back to my code, or this is the code. I go back to my Unity, right? And so our player bullet prefab has the script on it. If I go back to my scene, there's a little back button when you're in prefab view, right? Just to test, I'm going to go to my prefabs folder. I'm going to drag and drop it wherever. And if I hit play, does it move forward? Let's find out. Yeah, looks good to me. Cool. So a couple of things we should think about for bullets. We're going to be making a lot of bullets, right? Like a lot. So one thing we might want to do is make sure they destroy themselves after a certain amount of time, right? So this is a built-in Unity function. It's called, oh, my brain is blanking on it. Isn't it? Is it just invoke? I think, yeah, so invoke is a Unity function. Will you tell me, or is my .NET messed up? Okay, well, it's not going to tell me right now, but we're going to find out. So if I make a function here called die, now remember, this is me defining what should happen when I tell it to die. And so I'm giving the list of steps. We should just say destroy this. This is a keyword which refers to the current instance of the thing. So almost like English. When I die, destroy this. Kind of makes sense. The invoke function is going to call the die function after 5 seconds, right? So we can actually see this happen in the game. Let's go over to Unity. If I remembered the function correctly. A lot of people don't use this because it's kind of considered like it's a little sketchy, but it works. I mean, it's built into Unity. They use it. But there are better ways maybe. So I'm going to hit play and watch over in the hierarchy. We've got this bullet, and after 5 seconds, does it destroy itself? Did it? I guess so, because it's not moving anymore. Oh, it destroyed the script. Right, okay. Minor detail. So in this case, this refers to the player bullet component. But if I say game object, it will destroy the whole thing. See, this is good. I'm learning right here with you. I've done this a billion times, but Unity is so vast that remembering everything is real hard. So if we look, player bullet over here in the hierarchy, boom, after 5 seconds, it destroys itself. This is good because if you imagine somebody pounding on the button on the controller, there's going to be a billion bullets. Eventually, the scene would crash because there'd be so many bullets floating off into space. So we want to make sure that we destroy them after a certain amount of time. Great. So now they automatically destroy, they move forward. I feel like it'd be more fun if the speed was higher, so we're just going to bump it. Okay, I think the last thing we'll do is show you how to instantiate a bullet, and then we're going to be done. So I go to Unity, and like I said, we don't want a bullet just hanging around in the middle of space, so I'm going to delete it from our scene, but it's still here as our prefab, right? So what we're going to do is we're going to go to the player code, right? And there's a few ways we can instantiate things. I'm going to show you the first, and we might keep it, we might change it later. But what we need to do is we need to say public game object bullet. And now if I scoot on over to the inspector, why am I saying scoot so much? It's one of those days. So I go back over here and I look at the player, and we've now got a spot for a game object in the player script. Well, how about that? We have a game object prefab right here. So I drag and drop it over here and boom. Now the player knows where the prefab for the bullet is located. So in my script, I could do something cool. When I shoot, I'm going to use a function called instantiate. And I'm going to do bullet. And are you smart enough to give me the hints about how this function works? So instantiate is one of those functions that has like 20 different ways to be used. I don't know why my hints aren't working. Again, I don't normally use this computer, so I must have messed something up. But if you hover on it, you'll probably get the tooltip that says like, hey, here are some ways you can use the function. Typically, it wants to know, so that it knows that, but it just never heard of the function, huh? Okay. It wants to know the position you're starting it at. So I'm going to say transform.position. And I think if you do it that way, you have to put in quaternion dot identity. We'll see if my memory is working correctly. But so real quick, in Unity comes with a ton of built-in functions. Debug.log is one. Instantiate is one. Instantiate works in many different ways. You could just say instantiate bullet, and that would do one thing. Then there's a different version of the function which allows you to pass in two pieces of information. So maybe it's this, and then, transform, you can pass the parent or something like that. But it also supports a version with 3 arguments. That's the word for something between the parentheses in a function call that gives information about how the function should do its job. Don't overthink the programming jargon. Just think about it logically. If I'm trying to instantiate something, if I'm trying to, create something, I need to know, okay, what is it I'm trying to create? Where do I want it to live? And this is basically its rotation, right? So you can hand wave this for now. I don't want to get into it. Turns out mathematically rotations in 3D space are very complicated. And there's a lot of different abstractions going on to make it easy to work with. So this is sort of just default rotation, but in Unity, of course, it can't be simple. So they call it quaternion.identity. And so we could get further into that and Euler angles and everything. But for now, just know that this is what you do. So this might be right. My memory is failing me right now. So again, that function can be used a dozen different ways. So let's see if we found the right one that's going to work for us. I want the bullet to appear wherever the player is and then move forward when I hit the space bar. Have we done the work? Let's find out. So the game is running. I hit space bar. Hey, that's not bad. Okay. Might have to put in a cooldown, but for now, that's pretty good. Oh, interesting. It looks like they're vertical. That's weird. If I zoom out, is that true? Let's change our camera angle, zoom in a little bit, and then are they going back in here? Oh, yeah. Oh, because they're right. They're generating at the default rotation. Wow, the cute. It's like they want me to teach you. How about that? So real quick, yes, for now, I'm going to just call that fine. I don't want to get into a lecture on the difference between storing a rotation as a quaternion, which has 4 values, or a vector known as Euler angles, which has 3 values. It's complicated. It's not that important. All I'm going to do is, in this case, take the easy way out. I'm going to go into my prefab, and we're just going to make it, let's see here, 0. We can just make it like basically a sphere. For now, this is fine. We can play with it more. We can do it right later, but I don't want to overload you guys. That's quite a bit. So if one more time, I go back to Unity, I hit play. I'll make our game view nice and big, and I'll hit boom. Hey, that's pretty good. All right. Not bad for day one. In an hour, we set up some good coding structure. We installed our package. We learned about emissive materials. We've got our player. He's movable and can shoot. Not too bad. So I think that's good for a first day's work. We'll come back soon with another video, but in the meantime, let me know if you have any questions. See you then.